Hello guys, good afternoon. Again, this is Robert Bamba. So, kumusta kayo? So, ayan, I hope you're good with your first quiz, online quiz with Ed Modo. And likewise with those who have taken the first worksheet or the quiz one through the hubs. And for any questions, just please ask our co-teammates, Sir G, our former dean, and Madam Ice or Ma'am De Castro, and yours truly. So this is Engineer Robert Bamba. So I'll be still your presenter for this module, uh, or for the remaining modules. Okay, so let's talk about now and move on to the next lesson. So our topic for module 2 part 1 will be as follows. So we have here a logic formulation, algorithm using pseudocode and flowchart. So these are actually the two techniques on how to describe the algorithm of a code, which are actually the pseudocode and flowchart. And after knowing the concept on how to formulate this algorithm, pseudocode, and flowchart respectively, so we'll be using software, to simulate a flow chart. So you could actually do flow charting by your hand, or there are some open source software or packages that you could actually simulate flow chart of your codes. In our case, we will be using Flowgritim. Thanks to Flowgritim, so meron siyang free download. You could actually download that one. If you want, you could post this one and then just search into the Google and type Flowgritim. Yan. Para meron tayong automated simulation of the flowchart into an output. Maganda yon. So, especially for IT students, they are not just after the concepts, they are always after softwares and applications. Likewise with a graphical user interface. Then we'll move on the 2.2 of part 1 module 2 with the simple taking mathematical operators codes. Then we'll relate this in parallel to the input and output functions as well. Sabay, kung titignan natin, halos sabay itong dalawa na to, yung 2.2 and 2.3. So let's move. So logic formulation. So algorithm using pseudocode and flowchart. The question is, what is algorithm? So algorithm, a procedure consisting of finite set of unambiguous instructions, which specify a sequence of operations that provides the solution to a problem or a solution to a specific class of problems. For any allowable set of input quantities. So take note, meron tayong input quantities doon, para ma-process and then i-output. So bago ka pa makapag-manipulate o makapag-process, you need to have your good inputs to have a good quality outputs of the program. In short, algorithm is a step-by-step procedure to solve a given problem. So that is algorithm. And other may define this as a description of the codes or description on how to code the program. And usually they are actually written in English language, usually for a common language natin, sentences sila. Okay? Para describing how to code the problem to achieve a certain or a specific result. So yan. So we have defined algorithm, and algorithm has actually the following characteristics. So ito yung magiging guidelines natin sa pag-create ng ating algorithm, aside from the procedures on how to make or create an algorithm. So we have this first characteristics. An algorithm may or may not require an input. So bakit may or may not, kasi meron naman mga output results ng program natin na pwede namang sila ay walang required interaction with the user. So maybe it's just a program that would output of disseminating an information, no? Or relaying code or logos, no? Or simple pictures, no? So but most of the times, especially for complex problems, no? Or complex programs, it always requires a good input. I'm always saying a good input kasi kailangan natin ng good input para mag-yield tayo ng good quality output. Then of course, a good quality output, no? Each algorithm is expected to produce at least one result and it is for finiteness. It should be definite, no? There should be intact and clear output result. It should be not big or ambiguous. And again, after achieving the process or after processing the raw data from the input side of the customers, so we must inform the user of the program that the program has already been ended. So kailangan finite siya. Hindi siya letting the users formulating some questions on their mind na, oops, nasan na? So kailangan tapos na yung program. Bigyan natin ng information na the program has been ended. So it should be finite. So how to write the algorithms? So we have this here, of course. You need to define the algorithm's input, no? So pag nag-interview ka ng customer, try to catch up as much as possible lahat ng parameters na kailangan na encode sa yung program, no? Some of the inputs na manggagaling sa customer, usually hindi naman lahat yon ay kailangan. Minsan redundant na nga, hindi kailangan, or some inputs may be trash, no? So parang basura lang tong mga ibang data na to. What do we mean when we say define the right algorithms input? Dapat kung ano lang kailangan, as is lang, no? So hindi na masyadong mapalabok. So just to be concise and clear about the inputs. Remember yung quality. So for example, we will give a simple example, no? So wag muna tayo sa real life application which is complex yung mga situation na yon, no? Magbigay man tayo ng simple program, no? Or to problem to create a simple algorithm. Like for example, we want to calculate the area of the rectangle. So what would be the input then? So kapag rectangle, geometry, so alam natin na yung mga dimensions, and these are actually heights and width. So we have defined the inputs. In this case, very simple inputs lang, height and width of the area of the rectangle. Now next, define the variables. So after defining the variables, of course, anong klase sila? Baka ano to, string lang ba to, or are they actually numbers, no? And in numbers, meron tayong iba't ibang klase ng type of numbers like integers, real numbers, and so on and so forth. So we must define the variables. And of course, in defining the variables, of course, dapat may meaningful name yung variables natin na madali silang maintindihan. Kung para saan sila gagamitin, yun na dapat ang gagamiting terminology. Like for example, height, spell mo na right away height, no? Lalo na kung complex yung program, tapos gagamitin mo lang small h, tapos doon sa ibang program part, sa ibang part ng program or sa other subroutines or subfunctions, merong capital H. So paano yun? Magkakaroon ng conflict ng definition ng iyong variable of height. Likewise with width, no? So dapat concise, no? And in this case, instead of using H and W, as I have mentioned, height and width, kompleto na para madali siyang maintindihan. And besides, pag nag-review ka ng codes mo, madali mo siyang ma-notice agad. So if you want to find or Alt F or Control F to find a certain variable, so madali na siya. And of course, you must use now these input values, no? So usually yan na pa-process na natin, gagamitin natin yung mga yan. And then to solve the area, of course, we need this variable input variable height and width, no? So an algorithm's operations can take the form of multiple steps and even branch depending on the value of the input variables. In this case, simply lang um, computation lang ng sum ng or rather area ng rectangle, no? In case of the rectangle, output will be the value of the product of the height and the width, which is actually would be stored on the area variable, no? So area variable. So the next, let's create a program that will display the sum of two integers. Ouch! Anak, ba't ka sumilit? Kin, hindi ako matatapos. So let's formulate an algorithm for this simple problem. So let's read the problem first. So create a program that will display the sum of two integers encoded by the user. So pag-create natin ng step-by-step description for the algorithm or ng code natin, so we must take into account about the mga keywords sa written problem. So written problem in a sense na meron na tayong written problem, hindi siya verbal, but most of the time through survey or may format tayo ng question sa customer. If you are in a company of that cater ng programming or making system, usually may formatted paper na yan na sinusundan on how to ask questions at ano-ano yung dapat itanong. Usually yung mga randomized question na lang ay additional yun para makadagdag pa ng maliban sa formatted step-by-step questioning, no? Kasi baka may mga surprises tayo na magagaling sa customer na mas maganda pala yung mga bibigay na lang inputs or yung gusto nilang palabasin sa output program natin. So anyways, let's go back to the basic concept muna. So ano-ano yung mga keywords natin dito? So ayan. So pag sinabi nating display, so very good. So kailangan natin ng output, no? Take note, kapag nagdi-detect tayo ng mga keywords, kung ano yung i-describe natin, kailangan lang natin isipin yung IPO, input, process, and output. So in this case, output, display. Ano yung di-display natin? So sum, no? And then bago mo makuha yung sum, syempre may process. So ano yung process? Mag-encode or magko-compute ka ng sum. Bago mo makukuha yung sum, kailangan encoded value magagaling sa customer, di ba? Kaya may encoded integers. At take note, hindi lang basta numbers. In this case, dinefine niya pa pati yung data type o yung type ng number, which is o yung dalawang numbers, which in this case integer sila, no? So input, process, output tayo. So let's start. So in this case, may tatlong variables ako nakikita, right? Or nakikita natin yung dalawang encoded integers tapos sum. So mag-assign tayo ng alphabet sa mga to, no? So oops, ay papapap tong si ano, sino yan? Okay, let's continue. Naka-istorbo. Excuse me, medyo maingay lang sa labas. Okay, ayan. So choose 3 alphabets to represent. Post ko lang, medyo maingay sa labas. Okay, let's continue guys. Ayan, let's go back. So medyo makulit lang yung dalawang chikiting kadan. Okay guys, so let's assign 3 variables, no? 2 integers and for the sum, no? And then after which meron tayong mga variables. Natural lang, tatanungin na natin yung ano, yung user to encode the 2 variables. Pag naka-chop na natin, na-encode na niya sa keyboard, meron na tayong i-calculate or ipaprocess. So input number 1, step number 1 and 2, process we have here calculating the sum. So we formulate a formula dito na for the sum. And then of course, pwede na tayo mag-display ng output. And then for finiteness characteristic, it must be considering the exit step, no? So para alam naman ng user tapos na yung process. Yan. So, yun yung algorithm. So, makikita natin, it's just a simple of series of sentences or step-by-step description of how to code the program. Then, one technique to describe the plan of coding, so we use pseudocode. So, medyo mas shorthand tong pseudocode compared to algorithm. So, tinatawag ko itong parang barok kasi shortcut usually yung mga words dito. And it is actually in a program-related way of describing the code. No? When you say program-related way, yung mga ginagamit natin mga words dito, it's almost or it's nearly the same as the codes ng sa language natin na programmer, no, yung C programming language natin. So very much or very near na yung terminologies na ginagamit do kukumpara natin sa code, sa aktong code. Ayan. So a method that allows a program to represent an algorithm is in a more programmer related way is what we call pseudocode. So ano yung mga do's and don'ts natin? Those muna tayo siyempre. It must be simple and concise, and we must have a related naming convention. So ito yan actually mga characteristics na diniscuss natin, no? Part pa rin ng characteristics to. Simplicity, intact, concise, and proper naming ng variables. And don'ts of course, it will follow na kailangan ma-avoid natin ang abstract point of view ng ating description through pseudocode, and it should not be in a generalized format, kasi pag general ka, malawak yung nakikita ng user natin or ng nakikita natin sa code, no? So dapat specific. So parang sa thesis, parang the general objective in general, and then the specific objectives are as follows. So ganun din dito, no? Dapat specific siya ng pag-define ng variables, ng process, ng output. So let's try this one. Let's convert the pseudocode of the previous problem. So encoding two numbers and solving for the sum. So una, finiteness, it should start muna, no? Begin. The next step is yan, sasabihin na natin, i-define na natin yung mga variables. In this case, ang allowed lang na type na gagamitin ng integers are or numbers are of the integers type, no? So whole numbers sila. Like for example 0, 1, 2, -3, so ganun lang sila. Hindi kasama yung fraction. So if you want, pwedeng real numbers kung may decimal, but in this case integer type. So ayan, first num, second num, so may meaning, di ba? So alam na natin na ito yung unang number, ito yung second number, unlike x, y, so medyo vague din siya ng konti, no? Encode first num and second num, dahil na-define na natin yung variables na gagamitin, please encode na. So yung user kailangan ma-inform na natin na mag-encode na siya ng dalawang integer numbers. And then pag nakuha na natin yung integer values, of course it's time now to process, no, the sum, that it is actually the sum of the two addends, no? And then of course na-calculate natin its output sum. So kumpara dun sa algorithm sentences, ito it's parang baroque type ng algorithm, no? Ayan, so hindi naman parang baroque pa naman talaga ito, pero in a meaningful way ang pagka-baroque niya pag di-discuss niya or pag di-describe niya ng code natin. Ayan. And so yan. So let us try writing both of the algorithms. So comparison lang ng dalawa. So pakita na natin right away. Ayan. Ayan, no? So for example, ang problem ay to compute for the average of the 4 grades, no, ng isang estudyante. So in this case, ang algorithm, begin, then step number 1, input the set of grades. So yung 4 na grades. And then, so, yung description ay mag-input ng grades. Pangalawang description ay calculating the average by summing up the grades then divided by 4. So, description on how to calculate. Then next is, meron tayong sitwasyon, another requirement sa user natin is kung daw less than 75 kailangan makapag-output tayo sa screen ng failed, else output passed. So yan ang description ng code natin. Then for finiteness, again, end. Compare natin sa sudo code na yon, barok natin ang style nitong algorithm. So ito siya, begin. So initialize, so define variables. So if specific na, G1, G2, G3, G4, ave for average. And pwede man lagay na rin dito yung type ng variables, no? Pwedeng real or integers or float, yan, rather, no? Then dahil na-define na natin, mag-ask na tayo sa user ngayon. No? So dahil meron na tayo ng values ng G1, G2, G3, G4, so before we could actually compute or process the average, of course, kailangan yung raw data natin magagaling sa user. So ask natin ng input ng G1, G2, G3, and 4. G4 rather, no? And then here comes now the raw data. Likewise, no, or hence we could actually right away compute for the average by summing up G1 plus G2, G3, G4 divided by 4. And then there's a condition, no, na nire-require ng user or ng customer mo. For example, test if the computed ave or average is less than 75. If it is, then print failed. Otherwise or else, print passed. Yan lang. So dalawang output natin na pagpipilian. Kapag less than 75, failed. Kung hindi, passed. Greater than 75 or 75 and above. Tapos finiteness, end. So tapos yung program. So that's how we compare algorithm versus pseudocode. So next, type of description of algorithm, or how to describe the planning of the codes, or how we attack codes, no, or how we the style of coding, no, is through the description ng code by using flowcharting. So flowchart, as the name suggests, charts, no, yung flow ng mga charts. Yan. So napaka-literal, no? Flowchart. So flow is the flow of the charts. So we have charts na kailangan i-consider at meron silang direction ng sinusundan. So usually may arrow side dito. So by looking at the flow chart, one could actually understand the operations and the sequence of the operations. Ko ano yung ibig sabihin ng operation at paano siya mag-flow in a sequential manner, no? Hence, ang flow chart is just like an architect or an engineer or building structures na ginagamit nila yung what we call the blueprint, kumbaga. So may layout. Yan, picture kasi siya. So here are the symbols. So what are charts and symbols used in flowcharting to describe the codes? Connector, small circle. Gagamitin natin to kapag some part of yung paper natin, marami na yung mga charts dito. Then continue natin mag-drawing ng mga charts on the other side. Lagyan na lang natin ng connector. So for example, connector, small circle with written letter, for example, A. Tapos dito, continue mo dito, dapat parehas yung identifier ng connector natin, A. Ayan. So connecting lang. Just to connect some directions of flows or directions of the charts. And it actually prevents the reverse flow. Kasi dapat talaga may direction. Hindi pwedeng, oops, mali, pabalik dito. Hindi. Tapos pagtapos ng process na to, tapos na dyan, next flow na. Hindi pwedeng magre-reverse. Oops, yan, camera. Yan. Reverse flow. Yan. It's always one-way direction. Kumbaga sa daan, do not enter one way only. Yan. So, one-way direction. Then, process indicates any types of internal operations. So, manipulation, calculations, and any logical operations nandito. No? Pinaprocess na natin yung na-encode natin data or raw data. So, rectangle naman siya. Yung input-output naman, slanted. Slanted. Yan. 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 Nasa may camera nyo? Pabaliktad sa salamin. Ayan, ganyan na lang. So, slanted para rectangle or parallelogram. No? Diyan natin lalagay yung input and output kailangan natin. Then, meron din tayong kamukha nung kanina rectangle, pero meron siyang dalawang lines on both sides. And these are actually the predefined process symbol. So, ano itong mga to? Used to invoke a subroutine or an interrupt program. No? So, ibig sabihin, in this case, kung meron tayong main program, meron tayong subprogram, no? Kung meron tayong process dito na rectangle ginagamit, dito naman, pagpunta mo sa subroutine para matapos sa main program, meron tayong predefined process using this symbol. Use to invoke a subroutine or an interrupt program. Now, ito yung isa sa pinaka usually naglalaro ang logic natin dito sa coding. No? Ito yung decision symbol, yung diamond shape. Answerable by yes or. So again, ang ating diamond symbol for flowcharting is answerable by yes or no. So again, ito yung sa naglalaro tayo ng logic natin dito sa diamond shape na to na symbol ng flowcharting. Okay. So next is of course to be finite. So isa sa mga characteristic, of course, magkaroon tayo ng finiteness. Of course, it must start at tapos may katapusan. Alpha, omega, kumbaga. No, so, end. Ang symbol natin to parang oval ng track and field, no? Ayan, yun ang symbol natin. Ito. Then, of course, showing the direction of the flow. So, parang ways, no? Tinuturo ka, papunta ka na, anong lugar ka na. So, showing the direction of the flow. Ayan. So, let's set an example of making a flowchart, no? Written flowchart, a handmade flowchart, kasi merong flowchart na pwede natin magawa through software, so using the flowgrid. So after this example, I'll show you the software, no? Pero handwritten muna tayo, sa concept muna tayo ng mano-mano. So let's create a program flowchart that will display the sum of the two integers encoded by the user. So ito yung problem kanina, ang algorithm, nilagyan natin ng pseudocode and algorithm description. Ngayon, describe natin through flowchart layout. Okay. So again, kailangan magkaroon muna ng beginning, no? So begin, ayan. So ito yung sa left side, yung kanina nagawa na natin yan, yung Alabarok type of description, pero a powerful type of describing a code, no? So begin, then of course yung defining or declaring the variable. So kailangan natin ng parallelogram. So input, output, dyan natin nilalagay. So in this case, mag-encode yung user, lalagay natin yung num1, num2. So tinatanong yung num1 and num2, at specific siya sa type ng variables natin. It is an integer type, so kaya int. So and then of course, pag na-define natin, so pwede na natin gamitin yan sa process symbol na rectangle para makompute natin yung sum. Ayan, sum is equal to num1 plus num2. Pag na-sum up na natin, of course, magkakaroon na tayo ng output. So again, input, process, output, i-print na natin yung sum. So same symbol pa rin, pag input parallelogram, output parallelogram pa rin. So print sum. Ayan. And then of course, malaman natin na tapos na yung ating code. So end. So ganun lang kasimple ang pag-create ng flowchart. In this very simple problem, so madali nating ma-define ano ang flowchart in comparison to pseudocode. So ganun lang mag-create niyan, no? So siguro mas maganda makita muna natin yung software, so para maiba naman, no? Bago ko tuloy itong mano-manong pag-draw ng logarithm or ng what we call flowchart. Okay? So in my case, ito na yung flowgrid na sinasabi ko, flowgrid, no? na na-download ka from Google search engine. So open source naman siya, you can download this. Madali lang naman siya. Just type this logarithm on search engine Google, then diretso na. So pagka-click mo ng I agree, salamat naman sa mga developer, meron tayong open source logarithm. Try natin mag-simulate, no? From handwritten kamukha nung kanina, ngayon naman via software. Actually, nagsa-simulate din siya ng output na kagad eh. Yun ang kagandahan sa logarithm na to. So click natin. Ayan. So right away, parang sa pagka-code natin, meron na tayo kagad ng void main, tapos closing return. Ayan. Or int main, tapos return 0. So ganun din dito, may main program kagad. By default, ibibigyan ka na ng main, start and end. Ayan. So in that case, let's for example, gawin ko na ng may kasamang decision symbol, no? Tanggalin na natin yung, or iwanan na natin yung sum of two numbers, baka mga boring naman, masyadong simple. Actually itong susunod simple din, no? Pero try natin. Okay, so click lang natin ang arrow nito. So ayan, meron tayong play dito. Pagtapos na yung nasulat or na-draw natin yung charts, pwede din itong i-play at makikita natin yung output. So double click natin to, mag-input muna tayo ng values, no? Or mag-declare. So, declare muna tayo ng variables para makilala ng computer kung saan i-store. Kaya yung mga variables, doon i-store yung mga values, no? Double click, ayan yung mga charts. So napakadali na. Double click, madali. Ito, declare. So double click natin. Anong di-declare natin? Dapat pakilala natin sa computer na meron tayong variables. So double click, unahan natin. So for example, I want to compute for the total bill ng customer sa isang restaurant, for example. Tapos sa isang restaurant, may parang may courtesy or medyo mabait yung yung mga customer diyan, usually for American style, ganun sila eh. May percentage pa nga ng tip eh doon sa mga waiter, ano. So lagyan natin ng variables, for example, kung ano yung total bill, no, or yung bill muna, bill ng customer. Then in this case, baka may cents ang bayaran, hindi siya whole number, hindi siya integer, real type na lang, no? Real. So pwedeng may fraction or decimal point ang whole number natin. So real type bill. Ayan, meron tayo. Input pa tayo ng declaration ng tip. Ayan, for example, may tip ang waiter or nang nagse-serve. So real number pa rin, no? So for example, $1.50. So kaya real type, hindi siya integer, whole number. No, real type ang gagamitin natin, data type. Ang data type natin is real, ang variable is tip. Then balikan ko, same declaration symbol ang ginamit ko. So mag-introduce pa tayo ulit by clicking the next arrow, declare, double click, and then tip. Type natin ang tip, ang type niya is real type. Then double click, click again another arrow, declare, para sa of course ng ating total bill. Yan. Say total, then bill. So yan, na-declare na natin, na-define na natin anong gagamitin na variable. So pwede na maging code ngayon yung customer or yung for example, yung cashier, no? So pwede na maging code. Encode ang cashier, input. So click natin ang input. So una, ano yung bill, di ba? Amount ng bill na babayaran. Yeah. So ayan. So input bill, again, balikan ko. Ayan. So input bill. Yan. So pagkatapos na-input na natin bill, bago natin pabayad yung total bill, compute muna natin yung tip, no? Double click, and then yung tip. Say magko-compute ka, so process 'yon. So assign. Rectangle di siya dito, no? So assign, double click, assign a variable which is actually tip, no? Then paano ba compute? Say for example, 10% nung bill niya ang tip, no? So, at by the way, hindi pwedeng 0.10 or kailangan na nandun pa rin yung 0. Say 0.10% of the bill ang tip. Yan. So, 0.10 times bill. Then, okay, naka-assign na tayo ng value ng tip. No? Ang tanong ay kung merong range. Lagyan natin ng decision symbol. Yung hindi siya masyadong straightforward na ano. May test case tayo. So, for example, if bill, for example, yan. Dito sa gitna niyan, lagyan natin ng decision muna. No? No? Tanggalin ko muna itong tip na to. Kailangan may decision muna. If, for example, bill is, say, less than. No? If bill expression, enter a conditional expression. So, if bill, for example, equal to or less than ang bill niya, babayaran ng customer is, for example, $25 din para magkakaroon ng tip. No? Or baliktad. Yan, baliktad. Dapat, halimbawa, pataas ng $25, magkakaroon ng tip. No? Greater than or equal to $25. No? Magkakaroon ng... If the answer is yes, so, kailangan magkaroon tayo ng computation dito ng tip. Dun sa true side ng decision symbol natin. So, kung computation yon, process, rectangle, double click, then the variable is tip. So, and then 0.10 times the bill. So, yung encode ng bill. Okay? So, yan. So, makompute na, and then, pag na-compute na, pwede nang i-print yung total bill. No? So, what about kung false siya? Kung less than, ang gagawin na? So, natural, ang tip 0, no? So, madali lang. Double click natin yan ngayon na ang tip ay expression niya. So, 0.00 walang tip, no? Times bill. So, ganun na lang. Para magkaroon ng action ang no side ng symbol na diamond. No? 0 times bill. So, 0 pa rin naman. Walang bill eh. Ay, walang tip kasi less than $25. So, yan. So, either of the two side, pwede na mag-print ngayon ng total bill, di ba? So, ang total bill, i-assign natin, double click, so, what's the variable? Total, na-define natin, na-declare na natin. So, ang total bill is just simply, of course, yung bill niya, babayaran niya, plus yung tip na kinompute natin. So, ayan. So, na-compute na. So, again, ulitin natin. Declare, define variables, gagamitin na yung variables. Tapos, in this case, bago tayo mag-manipulate or mag-compute, mag-decide muna, may test case. No, tapos, process. So, input, process, output na tayo. So, process to. So, output. So, ano yung output ko? Di-display ko na, of course, magkano yung total bill ng customer. No? Total bill, yan. Total bill, yan. So, since string to, again, pag string double quote, tapos, total bill, yan, ganyan lang. Kasimple ang string natin. Tapos, so, anong ilalagay natin? So, doon sa coding ng C natin, naglalagay tayo ng ampersand, tapos yung variable na may value, tapos ipapasa natin sa loob ng quotation, no? Yung placeholder na may format specifier. In this case, wala ng comma. So, ilang pinakaiban doon. Pero don't worry, don't be confused. We'll be discussing more on the hard coding natin ng program na yan, no, sa C. So, dito na lang, ampersand, no? Format niya yan, ampersand, tapos yung ating total bill. Total bill. Yun ang piprint niya kasi. No? So, yan. Natin, yun. So, no error. No? Again, ulitin natin, nag-declare tayo ng variables, ginamit natin yung variables, bago tayo mag-process, may condition. Kapag true, compute mo yung tip. Kapag false, 0 siya. So, tapos, pag na-compute yung total bill, mag-output na tayo. Let's run. Ayan. So, oops, parang may kulang eh, no? Parang, anong gagawin ko dito? So, okay, by the way. So, sa tingin nyo, anong kulang dito? Wala tayong wala tayong signal, anong gagawin, anong encode, di ba? So kailangan bigyan ng information yung user. So bago siya mag-input ng bill, so kailangan may output tayo, display tayo na double quote para sa formatted string natin. Please enter customer's bill or bill. Tapos mag-input na ng bill, di ba? Ayan. So try natin. Yun, please enter bill, di ba? So at least alam natin anong encode natin. Finiteness. So for example, $100. No, $100 ang enter. Ang sagot ngayon is total bill is $110. So that's the good thing with this flow grading. It's not just a simple description of the code or blocks na ibibigay sa'yo as well as rerun na, no? Yun ang kagandahan. So, actually, coding ito no? So, sa Turbo C++ Borland natin, kailangan natin mag-code ng mga syntaxes, no? May rules pa nga yun, no? Ito, right away, meron na siya. So, it's good thing to use this one, no? But, hindi natin maintindihan to kung hindi muna tayo magtuturo ng concept. Hindi tayo mag-software mag-jump ng software right away kung hindi natin matututunan yung background ng mano-mano. So, just like in statistics, when I used to teach in statistics, long method muna, pagkatapos gagamit kami ng software. So, di na lang tayo mag-software. Take note, hindi ka kaagad makakapag-software, hindi ka nag-long method sa blackboard or whiteboard. No? So, that's it. The same is true with this programming code using the flow grading. So, thanks to flow grading, meron tayong ganito. Magagamit natin na sa tool. Okay, so let's proceed. Ayan. So next problem. Ayan, so madali lang siya din to. So nasaan na? Current slide pala yung napindot ko. Sorry. So wait lang po. Iba-browse ko lang. Medyo matagal. Ayan. Pseudocode. I'm sorry. So medyo nagtagal tayo. May pseudocode na rin tayo kanina. Tapos na tayo dyan. Sorry. Okay, come on. Tapos na rin tayo dito. Next problem na tayo. Yan. Write an algorithm and a flowchart to find the smallest of two numbers. So, ibig sabihin, baging code ng two numbers, tapos i-print natin yung mababa ang value sa dalawang value na in-encode natin. So, ilang ibig sabihin yan. Sa pseudocode, of course, define natin yung variable. Tapos ng begin, input two numbers. So, say num1, num2. So, dahil meron na tayo, gamitin na natin. No? I-process na natin. Pero bago i-process yan, kailangan may condition. Kasi, find the smallest, no? Nung dalawang in-encode. So, in-encode ang num1, num2. If num1 is less than num2, then print smallest is num1. Otherwise or else, yung isa, di ba? Yun yung smallest. So, print smallest num2. So, end if na nun. Otherwise, stop, no? So, print smallest kapag num1 is less than num2. Kung hindi man satisfied ang condition na to, yung diamond symbol dyan, else, print the smallest is num2. End if. So, kung may if dyan, may end if na dito. So, stop. Ayan. So, begin. Kunin yung dalawang number. And then, test condition. If it's yes, print smallest. End if na doon. Kung hindi man, dito sa left side, no, yung sa left side, no, hindi ko lang nasulat yung yes sa right, yet no dito. Kung no, print largest number is num2, no? Then end. So ganun lang kasimple. Ito, medyo bigyan natin ng konting challenge ng develop natin yung problem. Say pseudocode and flowchart to find the factorial of a number n. So ito ay isang number, hanapin natin daw factorial. Take note, ang factorial is simply the factorial itself tapos multiplication ng decreasing by 1 until ma-reach natin yung 1. So, ibig sabihin, kung 3 factorial, 3 times 2 times 1, tapos na. Ano yung product ng tatlo na yun, di ba? So, yung ibig sabihin ng n factorial. So, paano natin i-formulate ngayon to? So, ang n walang problema. ang mag-encode sa user nito kasi siya yung naghahanap ng n factorial siya magdi-declare ng value ng n. Ang problemahin natin ngayon dito, tayo ang nagpo-program, paano natin i-multiply ang n sa 3 times 2 times 1. Depende sa value ng n, no? So, ayan. So, in this case, meron tayong nag-decrease na number dito, no? So, or pwedeng the other way around. Mag-set tayo ng counter. Say counter initially is 1. Susunod, increment natin by 1, magiging 2. No? Increment natin by 1, magiging 3. And so on and so forth. Hanggang ma-reach natin yung kinukuhang factorial na number na gusto nating makuha factorial. No? Ayan. Ang pseudocode yan, begin. So, ang hint doon, dapat may taga-abang tayo na nagka-count ng nag-reach na siya sa n. No? Starting from 1. So, ang counter natin starts with 1. Then, increment natin by 1 until. So, let's consider ng problem na to, no? Pseudocode and flowchart to find the factorial of an n value, no, or n number. So, ano ibig sabihin ng factorial? Ibig sabihin ng factorial, so n factorial is multiplication ng increasing value, initially 1 times 2 times 3 times and so on and so forth hanggang ma-reach natin yung n. So, doon sa step ng pagbuo ng algorithm natin or ng pseudocode, so sabi niya, define mo yung mga variables. Una, may obvious na tayong variable which is n. So, initialize na natin yun or declare natin yun. Tapos yung factorial, natural, yun ang hanapin kong value. So, represent natin ng f. So, meron na tayong input value magagaling sa user, n, yun ang hinahanap ng factorial. Tapos, f, factorial na isosolve natin. Calculate natin. So, ano pa? So, ang hint natin dito ay lagi nasa formula lang naman So, mapapansin nyo, nag-i-increase by 1 ang pag-multiply. So, dapat meron tayong container or variable na nag-i-increase by 1 din until ma-reach ang value ng n. Until ma-reach ang value ng n. So, tatlong variables. Input, n, ang factorial na hinahanap, tapos yung counter na mag-aabang na-reach na natin yung value ng n. In this case, 1 times 2 times 3, and then say, ang n ay 4, edi stop na siya nun. So, yan, na-define na natin. So, gamitin natin sila. So, use daw yung mga variables na yun, sabi dun sa step. So, read the value of n. Then, initialize natin yung factorial at yung counter. Yung counter, nag-start siya ng 1 kasi obvious 1 to. Tapos, increment natin by 1 yan. Plus 1, 2, plus 1, 3, and so on and so forth hanggang ma-reach ang n. Ang factorial, initiate natin ng 1 lang problema. Kasi kapag 1, ang halimbawa, 1 ang naman nilagay ng user, tapos na yan. 1 times 1, 1 na sagot. So, print na. No? So, kaya ang lowest value nilagay 1 ng factorial. So, I think that's obvious. Tapos, ang test condition natin, yung counter dapat, check mo kung abutin na niya yung n. No? If it's less than or equal. No? Kapag habang less than siya, hindi siya hinto. Hanggang na-reach yung n, okay na. So, pwede na naman mag-print ng value ng factorial. Pero ang tanong, na formula ng factorial. Ang factorial ay ito ngayon. So, counter, since nag-i-increase to, ano yung initial value na, ano yung pang multiply natin? Alam mo, counter ng sarili niya. Hindi rin naman ng n. Kasi kung n siya, na-reach na kagad yung n value. So, that's factorial. Ayan. So, factorial is equal to factorial itself times counter. Ayan. Kasi nag-increase yung counter. Ayun. Factorial is equal to factorial times the counter. Ang counter ngayon, ina-upgrade natin. Ina-update natin by 1. Or ina-add natin by 1. So, ayun. Ng counter, pagtaas natin na-compute ng F dito, update natin to. Initially 1, dapat maging 2. So, maging 2. Dapat maging 3. Dapat maging 3. So, in this case, balik ka na dun sa step habang hindi pa nasasatisfy yung itong condition na to. So, ayun. Tapos, display na lang F pag naabot natin yan. So, support natin yan ng using the flowchart. Ito yung kagandahan sa flowchart. Makikita mo yung flow niya kaagad. Yung sa algorithm, yung word sentence by sentence, i-imaginein mo. Unlike sa, imaginein mo, papunta ka dun sa step 3. Unlike pag diagram siya or chart siya, makikita mo yung flow agad eh. Okay, try natin. So, begin, read n, or input n, then initialize natin yung dalawang variables, yung factorial tsaka yung taga-abang kung equal na sa n, si counter. Tapos, ito yung decision. Ang tanong, check if the counter is less than or equal to n. If it's no, ibig sabihin, print F ka na. No? Ibig sabihin, greater than na siya. No? So, no, print na siya nun. Kung habang less than siya, habang less than naman siya, yes, habang less than, compute mo muna yung factorial. Yan. So, tapos, update natin yung counter, tsaka bumalik doon. So, simulate natin. Halimbawa, ang in-encode ng user ay 3. Ayan, edi 3. So, is 3 less than or equal to, I'm sorry, if value of counter is 1 less than, basta 3. Hindi. Is it equal to 3? Hindi. So, dito ka. So, ang factorial is equal to 1 times 1. So, 1. Increment 2. Galing dito. 2 less than or equal to 3? Yes. So, ang counter na natin 2 times yung updated value ng factorial dito, 1. So, 2 ang sagot. So, 2 na ang value ng factorial. Tanda natin. Tapos, dito ang counter, 2 na siya, magiging 3 plus 1 eh. So, 3. So, is 3 less than or equal to 3? So, yun, equal to 3. So, yes. So, ano yung previous value ng factorial? 2 times 3. That's 6. Okay, 6. So, baba dito. Counter ngayon ay ano ang value? 4. 4 na yung counter. So, 4. Is 4 less than or equal to n? Hindi. So, no. Punta na tayo sa no. Piprint na natin yung factorial, which is, yung previous value is 6. So, the end. So, ganun lang siya. Okay? So, ayun kagandahan dito sa flowchart versus sa pseudocode. Nakita ko agad yung flows ang kababalik eh. Visually. Unlike dito, sabi niya, go to step 3. Okay, go to step 3. Pero nung binagawa mo pa ito, isipin mo nasaan eh. Pares mong isipin. Pero ang advantage nito ngayon, pag nakita mo yung dalawa, okay, ito in direction, no? Nakita ko agad. Ito, imagining ko pa. I-simulate ko pa sa utak ko or sa isip ko, sa brain ko, di ba? Okay, pupunta pala siya doon. Yun. So, may advantage din yung flowchart, no? Okay. So, ayan. So, that's it for our part 1 ng module 2, no? So, nagawa na natin, na-define na natin flow algorithm, yung algorithm, pseudocode, and flowcharting. Tapos, kagandahan, meron tayong software na na-download, which is Flowgrithm, thanks to Flowgrithm, an open source. So, you could actually download yun, no? Para makapag-simulate na ng output. Yun ang kagandahan sa Flowgrithm. Meron siyang flowchart, tapos mas simulate mo na rin yung output agad-agad. No, machi-check mo. So, parang nagko-code ka na actually doon sa flow grading. Okay, so for any questions or comments, chat nyo lang kami, ng mga ka-teammates ko, si Sir G and Ma'am Ice. So, see you part 2 ng module 2 natin. So, okay guys.